Hello, this is a very quick introduction and demo to the open source tool Scoop. Scoop is very similar to the Shovel plugin for RabbitMQ, with the difference in that you can specify how many messages you want to move from one queue to another, rather than moving absolutely everything. So what we're going to do in this very quick and dirty example is spin up a new Docker container that's running Rabbit, and then run the Scoop consumer to show how we can move messages. So if I just open my command line, and we will run this command to pull down the RabbitMQ image, and we will create a container. Lovely. So if I check my Docker process list, I can see the RabbitMQ instance running. And whilst that's setting up, we will log into this instance, and we will look to install the Scoop consumer using the documentation from the website. So I'll just upgrade a few things and then install the curl command. Perfect. We'll just verify that that's been installed correctly. Great. So if we head to the GitHub website, we can see from the README, as we scroll down to the install commands here, we can simply pull down the binary executable using curl, which we'll do. Scoop can be installed absolutely anywhere. You can define where your Rabbit instance is running by providing the IP address and the port, but for the case of this demo, we'll keep it nice and simple and just do it on the box directly. Notice I'm removing the sudo commands here because the Docker image that I'm running does not have sudo, and I'm already logged in as root. Great, so that's now moved the binary executable of Scoop into our user bin directory, so it's available globally. So we will head, now that our Docker image is running, to our local host, our mapped port 8080, which routes through to the RabbitMQ management portal of port 15672. We will go ahead and create a couple of queues for our demo. So the first one we'll create is new, and the other one we will make is old. Please note that we are setting the durability here to durable. And then we go to our old queue, and we just simply manually create a few messages in here just to replicate some sort of setup that you might have in your infrastructure. So let's just create, say, about 9 messages. Okay, we'll just wait for Rabbit to catch up. There we go, great. So we've got 9 messages there. So what we'll do is we will go to the command line, simply run Scoop, and move a few messages from the old queue into the new one. So if we go to the command line here, we clear this out. So the main one here is that we are defining the count to 3. We have a full verbose output so we can see what's going on. And the final 2 ones, if we take a look at the README, is the to and from durable flags, which simply means when we try and connect to the queue, when we declare our queue, it's going to use the durable flag. So if we run this, we can see that very quickly Scoop has successfully delivered those 3 messages from the old queue into the new one. So if we take a look at our management portal, refresh the page, we can take a look and see that we have 3 messages in our new one and 6 remaining in our old, which is great, and that's exactly what we wanted Scoop to do. And we can run this multiple times, so we can run exactly the same command again, and we'll move another 3 messages from our old into our new one. And again, we get told about the statistics of those queues. Very useful output there, and we can see that this is updated relatively quickly. Finally, just to show the ability of Scoop, we will increase the number of messages since we only have 3 left in our old queue, as we can see here. What we will do is we will move 4 messages, but our old queue does not have 4 messages, it only has 3. But what Scoop will do is it will stay attached as a consumer to the queue until it's finished what it needs to be processing. So if we run this, we can see that the process itself is still hanging, and it's still waiting for that 4th message. As you can see there, we're waiting for the 4th one. Now we have a choice here. We can either do Control C and cancel the process completely because we're happy with where we are, or we can leave this running until it has delivered that final message. So we can take a look in here and see that our final consumer is attached, our Scoop consumer. So let's just see this work by adding a few more messages in, just in a real world example. So let's add another 3 messages. And we should see that we have had 10 added there from our 9 that we had originally, and then 2 will remain in here out of our 3. And if we go back to the command line, we can see that it was happy that it reached number 4, that our 4th message, and then completed and removed the consumer. That's a very quick example of what Scoop can do. There's plenty more documentation within the README online, but hopefully this gives you a quick understanding of how it could be used within your infrastructure. Thank you very much.